Okay, me and Jonathan are doing this for NASA, and first we're going to start off with our sunlight. This is our sunlight, and this one has grown pretty big because it was the first one planted. We planted the second one because that one was growing slow, and we didn't think it'd grow that well. We thought it messed it up. This is our green plant light. It's growing the best because the green is going to the leaves and is trapping the sunlight into the leaves and making photosynthesis for more food. This is our blue light. It was one of the first ones planted. There was 3 plants in here originally, but 2 of them withered away. We don't know why. The one lasting grew greater than all of the plants in here, so we think we did good. This is our red light. It had 2 original ones, but they withered away because we think that the red light was too dark. And now in its place, more smaller plants are growing. Finally, our 5th plant, we decided to grow in total darkness to see what would happen. And it turned yellow. We think it turned yellow because the plants didn't have light to make photosynthesis and make its leaves turn green, so it used another chemical in its absence to make it yellow. The name of our experiment is Plant Growth with Color, by Jonathan Chesser and Dawson Bright. We're in Miss Wood's first period class at Lebanon Middle School. Here's our hypothesis in question. Our question is, does the color of light affect the way the plant grows and the size of the plant? Our hypothesis is, if the plants grow based on the color, then red and blue will grow the most. Planting the plants. Day 1, we planted squash under green, blue, and red lights. We also planted squash under sunlight and in total darkness. Growth. Day 9, growth under lights blue and green. No, we don't have growth for red light, sunlight, or in darkness. Growth again. Day 10, there is growth under the red and sunlight. We also have a second growth under green and blue lights. We have a sprout in darkness. Day 21, we actually have a sprout in darkness. We are very lucky to see this. It also seems we have another. Green is the greatest. Day 23, green is an excellent light, although in our research, green was supposed to bounce off. My hypothesis is, although green bounces off, more is stored inside the plant, and it can create chlorophyll and energy faster and in greater amounts than blue. Watering our plants. Day 25. At first we had difficulties deciding how much water and whether or not to give them equal amounts. But today it was resolved, and those are pictures of Jonathan watering. We decided to give each plant half a cup of water each day. RIP. Day 29. One of our red plants have withered away. We do not know what happened to it, but we believe that the red is darker and it made it have more heat where it withered.
Green supersizes.
Day 34. It seems green is still winning, and this is not what NASA had seemed to believe. They believe, as in the earlier slide, that green would bounce off and blue and red would absorb more.
Our hypothesis is being put to the test. Lighted plant growth. This chart is showing the different colors we use and the measurements. The red 2 and red 3 means the number of plants that are in each pot,
And the height is how far it got during our experiment. Like during day 7, it was that high, and then so on.
Sunlight planted growth. This is a chart of sunlight, and sunlight 1, and 2, means that we had 2 sunlights because our first sunlight grew slowly and we thought that we had done something wrong. So we planted another one to see if anything was going to happen.
And we did not have any in that other pot while we were doing the experiment.
Was it supported?
No, it was not supported by the data because red, instead of absorbing, withered away really fast. And blue, it might have absorbed it great, but it grew slowly and slowly, while green surpassed normal and even greater than that.
Careers. Some careers that involve this experiment are agricultural scientists and food scientists.
These careers involve this experiment because both scientists need to know what make the plants grow faster so they can have better performance in the future.
Our search site. All our information and facts are located off the official NASA website. Well, Miss Wood told us to just explore the NASA website, and we checked out a few videos talking about astronauts going up into space and going off to Mars and other different planets, and talking about how they would need to grow their own food and wondering what kind of light would work best for them.
Well, we decided the amount of water. That was an experiment too, because darkness, since it had no sun, would stay really moist, so we know we couldn't have too much. And then the lights, they needed enough to where they wouldn't wither away. So.
No, we did not.
Yes, it does, but that could help us in the future. That's just one mistake over the many.
Now or anytime soon.
That really depends because it has a thin atmosphere, so you can't really plant anything on Mars. But if we had the technology to make Mars have a thick enough atmosphere or something, we could use something as a solar panel and absorb the sun if we don't have enough.
We just decided we needed something to grow up instead of the produce growing in the ground to measure and see what was happening to it. I think it's fine just the way it is. It's surprised that starting this even grew.